Did you know that before the age of dinosaurs, many incredible animals of many shapes and sizes populated the Earth? Now, let's take a quick rundown of prehistoric times to learn more about the creatures inhabiting the Earth before the giant dinosaurs took over. The lesser-known ancestors of dinosaurs ruled the hot, humid Earth for almost 50 million years before the likes of Tyrannosaurus rex and Velociraptor came into existence. And it all started with the motion of Earth's crustal plates. Okay, we know a geography lesson isn't on your to-do list today, but it's going to explain a lot. The movement of the Earth's plates caused the fusion of land into a supercontinent known as Pangaea. The rest of Earth's surface area was occupied by a corresponding single ocean known as Panthalassa, crashing on the shores of the supercontinent. The Permian Era began nearly 300 million years ago, during which the first large herbivores and carnivores embraced the land and seas. After the end of the Ice Age, there was a hotter and drier atmosphere with melting ice caps and thriving green flora, and we know that the Earth became warmer and increasingly habitable. Flora had mostly ferns, conifers, and small shrubs, while the fauna, which is in the focus here, had sharks, bony fishes, arthropods, reptiles, and synapsids. Synapsids, or mammal-like reptiles. One of the significant events of the Permian period was considered the rise of synapsids, which were essentially reptiles with the appearance of a single hole in the skull behind each eye. For a long time, these synapsids were considered a part of the age of dinosaurs as they uncannily resembled crocodiles and dinosaurs, as witnessed in common examples like Varnops and Dimetrodon. By the end of the Permian, a population of synapsids had split off into therapsids. That's when the first archosaurs, diapsid reptiles, distinguished by the two holes in their skulls behind each eye, appeared. Nobody could have anticipated a 250 million years ago that these archosaurs would evolve into the earliest dinosaurs of the Mesozoic Era, as well as pterosaurs and crocodiles. If we delve a little deeper into the coexistence of these interesting creatures, we find out that these synapsids coexisted with anapsids. Take a wild guess about how these anapsids were characterized. If you guess that anapsids were distinguished as reptiles with no skull holes, then ding ding ding, you're right. Scutosaurus, a big awkward beast, exemplifies prehistoric anapsid complexity. The testudines, which we know as turtles, tortoises, and terrapins, are the only living anapsid reptiles today. Dimetrodon, the assumed dinosaur. By far, the most famous Pelycosaurus, a non-mammalian synapsid and a generalized carnivore, were Dimetrodon. Fun fact break. These non-dinosaur dinosaurs lived and went extinct tens of millions of years before the first dinosaur had even evolved. Even though they had a very prominent sail, Dimetrodons were named after the two different kinds of teeth embedded in their jaws. These jaws were sharp and pointy and built to dig through bone and flesh of prey. But mind you, this reptile's dental arsenal was no match to that of predatory dinosaurs that came later on. The most distinctive feature of Dimetrodons was their giant seal-like sail. It was phenomenal in what it adapted to do. Since this slow-moving reptile had a cold-blooded metabolism, the sails soaked up all the sun during the daytime and dissipated excess heat at night to regulate the reptile's body temperature. How cool is that? Imagine having your own personal temperature regulation device attached to your body, wiggling behind you. That's missing out on some perks because remember the bio lesson 101. We're warm-blooded, but you would be surprised to know that these splay-footed reptiles did not always have such a long tail. Old photographs and drawings of Dimetrodons display a very small, cute-looking, stubby tail. It was later on, in the mid-20th century, that archaeologists found fossils of long-tailed Dimetrodons. This is how we figured these reptiles lived in the nether regions as well. Evolution is real, kids. Amphibian, or more like amphibian. See what we did there? And no, that's not a clickbait. These slimy creatures, who only live near water bodies due to their restricted ability to lay eggs, only in water found themselves out competing during the Permian period by the more adaptable reptiles. Reptiles could venture further onto dry land to lay their tough-shelled eggs, which granted them with more mobility to colonize land. Larger reptiles evolved over time. The planet became hotter and drier. Reptiles spanned the evolutionary gap between large amphibians and the first dinosaurs. The amphibians of the Permian periods can generally be split into two groups: small and peculiar-looking lepispondals, and large and resembling reptile temnospondals. Because they were mostly aquatic or semi-aquatic, lepispondals were more likely to develop the slimy skin that sets the modern-day frogs apart. Microbrachus, another scary-looking amphibian, reminded people of salamanders. The best example of these salamander-looking creatures was the Diploceraspis. Diploceraspis, the hammerhead amphibia. There is nothing more fascinating than a boomerang-headed amphibian, Diplocalus, except another boomerang-headed amphibian, Diploceraspis. Diploceraspis, a close back-end cousin of Diplocalus, was a species of hammerhead amphibian that lived in present-day North America throughout the Permian period. This bizarre creature was a 3-foot salamander with a boomerang-shaped head. The horns, which gave them their distinct head shape, developed literally to outlandish proportions as these microsaurs grew to become very much larger. The Diplocalus and Diploceraspis are often mistaken for each other, but you can identify the latter as they are notably smaller in size. Was this strange skull used for protection against predators, a battle tool, or just a fancy way to show off to potential mates? It shall always remain a mystery. Eriops, Permian crocodiles. Amazingly, these snake-like skin amphibians resembled the modern-day crocodiles. These Permian species had a huge, sturdy body with broad ribs, a super long tail, a flat skull, and 4 short but powerful limbs. The archaeologists have observed sharp teeth with a distinct pair of tentacle teeth situated on the nasal area of their robust jaws. The fossils also indicate that these prehistoric amphibians featured huge eye sockets on their elongated skulls, as well as nostrils atop the beak portion of their heads. Euryops were carnivores which fed on smaller reptiles and amphibians, but that did not mean they were safe. The land animals such as Dimetrodons preyed on these water-bound prehistoric amphibians. Although Euryops possessed some terrestrial adaptations, its size meant that it was sluggish and burdensome on land. The limbs peaked from the sides and only just lifted the body off the ground. However, while in the water, Euryops had the buoyancy of the sea to support its mass, making it a far more active predator. Helicoprion, the shark with fruit roll-up teeth. One of the bizarre pieces of evidence paleontologists have discovered in the quest of prehistoric sharks is a tight curled-up coil of triangular teeth attached to the bottom part of the Helicoprion's jaw. The mystery is the technical functioning of this feature. Was it used to grind away the shells of swallowed mollusks, or did the Helicoprion unfurl the coil like of a whip to hunt? We can only guess because sometimes the natural world is as mysterious as our imagination of it. The head-scratching fact about the prehistoric sharks is that they survived 2 most deadly extinction events, Permian and Triassic. Arthropleura, a millipede larger than a human. Arthropleura is the largest land-dwelling invertebrate to have existed on Earth. It had the potential to grow over 6 feet in length with a width of 1.5 feet. Added to its massive width and height, this millipede had no known predators. While experts assume Arthropleura ate decaying organic waste that accumulated on the huge forest's moist floors, it might possibly have eaten carnivorous foods. In addition to insects, experts believe it hunted tiny vertebrates that happened to cross paths with the massive beast. Creepy, crawling, king of the forest it was. However, it finally became extinct as all life forms came to an end, but it was most likely because of climate change at the start of the Permian period. The earth became drier, making Arthropleura's survival more challenging. According to scientists, Arthropleura's closest modern cousins are from the Peniciata group. Fortunately, none of them grow to be 6 feet long. Meganeura, the large veined fly. Meganeura are often associated with modern-day dragonflies, but considering their structural and characteristics differences, these insects were commonly classified as griffin flies. The large size of these insects, due to a higher oxygen content in the prehistoric times, caused them to be much slower than the modern-day dragonflies. But as there is still a lot to explore about the prehistoric times, it is also claimed that these adult terrestrial insects had evolved in water and grew larger for protection against the high oxygen content in the air. Whatever the truth, these Meganeura were really mega, almost the size of a large bird like an eagle. It was the largest known flying insect species with a wingspan of about 2.5 feet. These and other gigantic insects did not evolve as the climate of the Earth changed. The decrease in oxygen content in the Permian atmosphere caused the extinction of Meganora and the likes of it. This great dying at the end of the Permian period encouraged different forms of terrestrial and marine vertebrates to dominate the Earth's ecosystems, leading to the evolution of dinosaurs. That's a wrap on today's video. Which of these prehistoric creatures did you find the most fascinating? Let us know in the comments below. Bye for now.